Start. So first of all, myself Lokesh, and I'm having around 5 years of industry experience. I'm currently working as a data scientist in a product-based company. So my expertise is building low-level machine learning logics and also tuning machine learning algorithms, and also UDF for time forecast analysis. Okay. So in this session, I will be teaching you the entire clustering algorithm, how it works, and what things we have to do. Okay. And if you have any query, you can reach out to me, right? You can raise your hand, you can ask if you have any query. Clear? Yeah. So before starting, I will just show you. So I have said some things like I was expertise in writing machine learning algorithms, right? And also building low-level system design codes, right? So what does it mean? I'll give you like a 5-minute sample, okay? And then we'll go with the session. Clear? Yeah. So let me share my screen. Yeah. Everyone, are you able to see this compiler or interpreter? Right? So, yeah. For example, if I want to print first 1,000 numbers, like what is the naive approach you would follow? You got my question, right? With the help of for loop or while loop, it's based on your convenience, right? So I'll just show you, like for a in range of 1 to 1,000, right? Print a, right? This is the logic which we follow. So what is the time complexity for this? You're aware of this concept, right? So like how much time does it take to? Okay, fine. So how much time does it take to run this entire code? Any idea? Yeah. So it is a for loop. The starting of the loop starts from with value I equals to 1, right? Yeah. And the loop ends with ends at 1,000. So it takes 1,000 iterations to complete this code. Am I correct or not? Right? So the time complexity for this is big of 1,000, right? If I increase n value to 10,000, it will big of 10,000 because it takes n number of iterations to complete this code, right? So let us make this code some more interesting. So you need not to worry about this code, okay? So I'm just giving a sample. So yeah. So if I run this, if you see, I have printed 1,000 numbers, right? Convinced, like everyone able to see this, right? So if you see here, what is the time taken here to execute this entire code? Some 0 point, everyone. What is the time taken here? It's around like 0.007023, some around milliseconds. It depends upon your computing power of the engine too. Like Mirai laptop uses now, it depends upon that too. Okay, based on the codes. So now let us see the same code. So remember this value. Okay, what is the value here? 0.007023. Okay, now noise. I will tell you everything. Okay. So no need to worry about this. So I want to show the difference. That's it. So I have written the same code, right? Right. So I have reduced the workers. And what is the time taken here? So we use a multi-processing to make our work easier. Clear? So the time will vary for every execution, right? You got my point, right? So first you have executed a code which prints 1,000 numbers, and then the same code which I have used, and I have, with the help of multi-processing module, I have used it and it printed the same result. Okay. So when you write this and when you execute this type of code in the real-time industry, it will be more faster. Clear? This is my work. So I have to ensure, for example, if you see earlier, everyone know about the application Hotstar, right? Right? Earlier, it used to accommodate only about 5 crore or around 10 crore users. Now it has the capability of accommodating more than 100 crores or 20 crores, I think. Right? How it happens? Because of the system based on logic. Okay? Yeah. So yeah, that's all. This is all about which I do. And now jumping into the session. Okay. So in this session, we will be discussing about the clustering algorithm, which is a machine learning model, right? And in this, we train the data, right? And we ingest the data into the model, and model will learn something, and we will get the output. Clear? Everyone are aware of the machine learning concepts here, like, or completely new to those concepts? Completely new. Completely new. Okay, fine. So EDA on data sets. Okay. So let us start with EDA. Okay. So why do we do EDA? So what does EDA stands for? Data analysis. Right. Why do we do EDA on a data set? For cleaning process. Yeah, cleaning. Right. Sorting. Why do you want to clean the data before ingesting the data to the model? Right. Every data set is a two-dimensional data set, sir. Yes or no? We are going to ingest the data set into model, right? We take the data set, we clean and we do some EDA operations on the data set, and then we ingest the data set to the model. That is what we do. Clear? Now, my question is, why do we want to clean the data? Data results. Yeah. So the main intention of doing EDA is to clean the data. Okay. The reason why we are doing this is, I believe in one thing. The thing is, the more accurate your data is, the more accurate your model output will be. Clear? Once again, I'm saying, the more accurate your data will be, the more accurate your model output will be. So if you are into any of these fields, data analyst, data engineer, or data scientist, in these three fields, okay, writing code, building pipelines is not a hectic task. Okay, making the code which you have written and the pipeline which you have built scalable to the incoming data is a task. Okay. For example, I am having a task which prints 1,000 numbers. It is working fine now. And then now a sender sends me 10,000 numbers, and now my system is getting hanged. Then what type of code it is? You're getting my point, right? Any confusion? Clear? Right? So here, for for these three principles, for the data scientists, data engineers, and data analysts, the main task is to maintain or ensure the code and the pipeline which you have developed scalable for the large and voluminous amount of data. Clear? Clear? Yeah. So to do this, first thing you have to ensure is you have to do EDA on the data. If you go for any data scientist, okay, they spend some ample amount of months for cleaning data, right? And then they will ingest the data to the model to get the desired result. Clear? So the main task is to EDA and then go with the model building. Clear? Okay. So in the EDA, okay, what are the main three things which you face mainly in the data set? Null values.
Missing values.
Okay. Missing values for null values are the same thing. Yeah, that is also a valid answer.
Outliers.
Outliers. The good thing. Right? Any other things? Future selection. Right? Future selection. So I will tell you. Yeah, before telling this, you are having you have a minimal knowledge or completely new to machine learning? Completely new to machine learning. Okay. So they have said this, you have some knowledge on building models. No? Okay, fine. No. Yeah. So here, what we do is I will go with the main things for the EDA. For any data set in the real-time industry or in any industry, the main three things which you face is null values in the data set, right? Which we say as missing values. The second thing is outliers. The third thing is duplicate selection, duplicate entries, and also future selection. These are the four things and the main three things which you have to do for an EDA, right? Now, you know about what is missing value, right? For example, I'm having a data set, some age and experience. Okay, for some of the rows.
Video.
So here, the first thing is normal consciousness. Null values means you won't be having any entry for the particular value in a particular column, right? Outliers means some points which show the abnormal behavior with respect to other points in the column, right? Do you get my point?
Yes.
What does outlier mean? Some points in the data set which show abnormal behavior compared to the other points in the column. Okay, let us consider I'm having a data set, as I mentioned earlier, age and experience. Okay, for 5 years or for 20 years, I'm considering an experience of 1 year. 25 years, I'm considering an experience of 3 years. Some 50 years, I'm considering an experience of 15 or 16 years. For 120 years, I'm considering an experience of 120 years of experience. Do you find any outlier in this? 120 years. How do you know that?
Because it is normal from the
Right.
outside of us.
A human being cannot survive 120 years, right? So a human being cannot survive more than 100 years, right? This you came to conclusion after having a clear inspection on the data, right? So when you come to industry, you are not the one going to decide that. We have a separate role called business analyst. Have you heard of this?
Yes.
Business analyst will tell you or will give you the clear insights of the data. On the top of it, you will write you will develop a code or pipeline on that. Clear? Clear? So your task is to, they will give some requirements. On the top of the requirements, you will develop the pipeline and you will develop the code. Clear, guys? Any queries so far? Any queries? Yeah. So now what I will do is, I have prepared some code and the entire model. Okay. So do we have some stylus here? So we yeah. Yeah. So before that, so in the machine learning, we have these type of categories. One is supervised. Second thing is unsupervised. Third thing is reinforcement. You told you don't have minimal knowledge. Theory knowledge. Okay, agreed. So just two meaning.
Screen marker ఉండేదా స్క్రీన్ మార్క్
Spoons. See, so as I mentioned earlier, we have three types of categories in machine learning. One is supervised, unsupervised, and reinforcement learning. Okay. So any algorithm which you build, which comes under these categories. Okay. The advanced GPT-5 transformers also will come under these categories. Okay. With the separate names called Bayesians and all these things. Okay. But any algorithm which you build, which will come under these three categories. Clear? Yeah. Now the first algorithm which I have told, the first category what I have told you, supervised machine learning algorithm, right? So what does it mean?
Labeled it.
What labeled it?
Was
Sorry?
It uses labeled data
For
executing
For training the model.
training model. Okay, fine. So what does label data mean?
Label data means
combination of dependent and independent variables.
Okay, what is dependent means again label data mean. So what is label data here? See, so when we build an algorithm, we ingest data. The first thing which I have told you, right? Here, when you ingest the data, we ingest output along with the input to get the desired result. Okay, the output which you are ingesting to the model to get the desired output, that output is called label data, right? The output is which is called a label, right? You ingest that output to the model to get the desired result. Okay, see, any machine learning model follow the same simple steps, right? Ingest data, the model will prepare insights on the data what you have ingested, and then it will give some output on the training data, right? So here, for the supervised machine learning model, you ingest the data which is having the output in itself. Clear? So when you ingest the data which is having output in it, it will learn something from it. It will learn some patterns from it, right? So for example, when you are playing any TikTok tic-tac-toe game or any other games like these type of puzzle games, first you won't be having any knowledge, right? After playing some scenarios and after playing multiple times, you yourself impose some new logics in your mind, right? On that logics, you will play with the opponent which you're in the scenario, right? So here in the supervised machine learning model, when we are having some 100 records in the data set, we will first split the data, first 80 records for for training, and remaining 20 records for testing. Okay. So in these 80 records, you pass input as well as output to the data to the model, right? When you pass it, model will learn something from it, right? And then after learning, you will say that the model has learned something. So I will pass a training data set to it, which is a test data, right? And then when you pass a test data, you will have output which you want, right? That is the approach which every machine learning model follows. Ingest data, model will learn something, again pass some data, model will give some output. Clear? So here I have told you, like, I am passing an output as an input to the model. So in this scenario, those type of models are called supervised machine learning models, right? You pass input as well as output to the model so that it will learn something. Okay, that output is called labeled data. Clear? Okay, I'm giving the rough picture like how it happens, right? Now coming to the second category of machine learning model, which is unsupervised machine learning model, right? Here, there is no point of output and input. Okay, you won't be having any input and output in the data set. You will pass the data set, it will find the patterns in the data set, right? It will find the points which have a similar behavior in the data set. Clear? So for the unsupervised machine learning algorithms, you will pass the data set. Okay, when you pass the data set, it will understand the patterns, okay, and it will form the clusters based on the similar behavior in the data points. Okay, so here you will deal with labeled data or unlabeled data.
Unlabeled.
Why?
The data will be in the form of various images.
Sorry.
I mean, the data will be in the form of audio, images, will be unstructured.
Bro, you can type in the chat. Who is that? Jnanendra, right? So you can type in the chat. Okay, fine. Yeah, no worries. So the main thing is supervised in the supervised machine learning model or in the supervised machine learning algorithm, we pass input as well as output to the model, and then it will learn something, and we again send some test data or train data, and it will give some output, right? For the unsupervised machine learning model, it doesn't follow like that. Okay, you will ingest the entire data set what you are having. Clear? What you do? You will ingest the entire data set what you are having. It will group the points based on the behavior in it, right? So the main areas we use this unsupervised machine learning algorithm is for email type prediction, whether it is a spam or not spam, right? And also like for finding, for example, if I'm using, you're aware of this Amazon websites, right? Right? And like it uses it to find like in which category I am having more business, right? In these type of scenarios, we use unsupervised machine learning algorithm. Clear? Clear, guys? And the third category is what does reinforcement machine learning model mean?
It will be
So here, sorry.
It will be on the basis of trial and error.
Trial and error.
Yeah.
Yeah, he's correct. So in the reinforcement machine learning model, the model learns based on the trial and error, false and positive, punishments and rewards. Okay, these are the three things where a reinforcement machine learning algorithm work. Okay, so if you are aware of, if I have a maze, like if I drop you there, if I tell you like this is the starting point and you will be having some ending point somewhere, you have to find it. You got my question, right? So there is a maze, I'm dropping you there, and what I'm saying to you is you have to find the ending point and then you have to come out of the maze, right? How do you do that? Which is a classic example for reinforcement learning. Clear?
Robotics.
So, sorry?
Robotics side. Robotics, self-driving cars.
Yeah, that is also a scenario. Yeah. So here what it will happen is, so you will teach an algorithm such a way for every good turn or every positive turn, you will award some points. Okay. For every wrong turn, you will give some punishment, some like you will decrement some points. Based on those scenarios, okay, you will get the desired output. The desired output here is the person will come out of from the maze. Clear? So stylus content stylus. Okay. Yeah, points. Sorry, you're saying something?
Sir, unsupervised learning, 80% of data need triangles.
No, we'll ingest the entire data.
100%.
Yeah, we'll ingest the entire data. Because here our task is to find like how the data points behave. Okay. Here our task is to not to get the output for the data points. Here our task is to find how the data points behave with the other data points. Clear? Yeah.
Only supervised learning.
Yeah, you will train, you will pass the data. Okay, any queries so far in the supervised, unsupervised, and reinforcement learning? Or you got a rough idea how it happens, right? Clear? Yes. Everyone? So should I go with the unsupervised? So the thing is, they have told you like you have an idea about supervised. So that's the reason I have prepared an algorithm for unsupervised. Yeah. See. So everyone, are you like aware of this platform? Google Colab. Why do we use this? Sorry? To run Python programs. We have programmers, compilers, and number of compilers. And what difference it makes? Sorry, you have said something. Train the models. I have VS Code to do that.
Or we don't need any libraries to install.
Sorry?
In Google Colab, we don't need to install any libraries.
Exactly. Yeah. So here, if you want to build machine learning models, if you want to do that in normal compilers, like normal interpreters or normal like platforms like VS Code or you name it, anything, right? You have to give another pip install command to install that library, right? For example, you're aware of the pandas library, right? Can I run that pandas library on the normal interpreter? What I have to do? I have to again go to the terminal and I have to install the particular command, right? So here Google Colab supports vast number of libraries. Clear? it supports vast number of libraries and you need not to install for everything, right? It also supports advanced spatial images and advanced spatial plotting, which is folio modules. It will also support those type of modules too. Okay, that is the reason we use Google Colab. Clear? Clear? Yeah. So I have a code. Everyone, good to see this, right? Right. So here, this entire code is for unsupervised machine learning algorithm. Okay. So what type of data we deal with here? Labeled or unlabeled data?
Unlabeled.
Sorry?
Unlabeled.
Unlabeled data. So here we won't be passing any input to the model. We just ingest the entire data set to the model, and then model will learn something and it will form some clusters and or it will group the data based on the similar behavior. Clear? Everyone?
Yes.
Clear? Yeah. So for example, you know 2D plotting, right? You know 2D plotting, right? So you have your books, right? I will give you some two-dimensional some points. Okay, plot those. Okay, open your books. Clear? Guys, you're getting me like what I'm saying, right? Or confused? Fine. Okay. So the thing is, I just wanted to start from the beginning, but they have told you have already idea about these models. That's the reason. You don't have. Fine, no worries. I will tell you from the start how it behaves and how to do that. Okay. Yeah. So note these points: 1, 2, 2, 3, XY plane. Those are the points in the XY plane. 3, 4, 4, 5. Okay. And 10, 11, 12, 13, 14, 15. Can you plot these points in the XY plane? Like, have you forgotten about? You know how to plot this, right? No? X and Y axis. 1, 2, 3, so on. Plot this. See, like, if you want to come into in the field of data science, you should be strong about vector algebra, differential calculus, right? Limits, and also like probability and statistics. These are the 4 concepts which you have to be strong in. Here. Now consider the points which I have given is a data set, right? Those are X and Y columns. Or those. What happened? Points. Yeah, once again I'm saying 1, 2, 2, 3, 3, 4, and 4, 5, 10, 11, 12, 13, and 14, 15. Done? Don't draw a straight line, okay? Just to plot it and leave it, okay? Just plot it and leave it. Okay? Yeah. So if you like everyone have done it? Don't draw, leave it. Leave it. So everyone have done that, right? Now, if you see here, have you noticing any patterns in the plottings which you have done?
X is increasing, Y is increasing.
Nice. Any other thing which you have noticed? See, in the plottings which you have done there, around 4 to 5 points are in one group and the remaining other points in another group. Yes or no? Right? This is called a clustering or unsupervised machine learning algorithm. Clear? So I have given you with the simple and basic data set, which is X and Y values. And then I have told you to plot it. And then you have plotted it. And then you have noticed some points which I have given around 8 points, right? Those 8 points, 5 behaved some common behavior, and the other behaved some common behavior, right? So in the clustering algorithm, you won't be dealing with the output, right? You will only be dealing with how many groupings you have obtained. It means how many points which you have noticed that are exhibiting similar behavior, right? So how many groups you have here?
Two groups.
Two. How you have said that? Because those points are nearer, exactly, right? Right? Those points are nearer to the other points from the other group, right? On basis of that, you have said it is like two groups, right? So in the clustering or in the unsupervised machine learning model, okay, which is clustering is one of the technique, okay. Here you won't be concerned about the output which model gives, okay. Here the main intention is you have to ensure how the points in the data set are behaving to each other. Clear, guys? Everyone? Clear? Yeah. So here, this is the same thing which happens in the real world scenario. Okay. If you consider the Amazon sales or Flipkart sales, or whether an email is spam or not spam, clear? These techniques or these scenarios come completely under unsupervised machine learning algorithm, which is clustering, right? Here they won't be concerned about the output which you are getting. They only concerned about how the points in the data set behaves with the other point. Okay. Now, so here, how many clusters or how many groups you have seen there? Two groups. So you have some consciousness. Based on your consciousness, you said that, sir, these are the two groups. One group shows like a similar behavior and other group shows similar behavior. Based on what? Based on what? You're saying that they are showing some similar behavior, right? Based on what?
Based on points. Yes.
Based on the distance between the points. Yes or no? So in those two groups, one group is having minimal distance from one point to another. Yes or no? Yes. And in the other group, those points are having minimal distance from the one point to another. It means these points exhibit common behavior from this group 1, and the other points exhibit common behavior from the group 2. Yes or no? Clear? This is what a this is what a clustering algorithm works. Clear? Clear, guys? Yeah. So here, like we are going in a theoretical way, we said in a simpler way, right? We have done it, so this is the two groups which it formed, and we have two clusters, right? How do you write that? How do you code that? Right? So earlier, if you want to build these type of models, you have to write around 250, 300 lines of code to get it, to get the approximate answer, to get the desired answer, right? So now we have a predefined model from SQL or the cluster, where you can directly import that particular model, k-means, right? So here I have mentioned from sklearn cluster import k-means. This is one of the clustering model which helps you to find the common behavior in the dataset points. Clear, guys? Clear? Any queries so far? So in the unsupervised, which is clustering algorithm, your main task is to find the points which shows a common behavior. Clear? And then you have to find how many groups which are having the common behavior. Clear? Okay. So how the code works is, here the code gives a centroid for each group. What does centroid mean?
The point of the midpoint of
God, answers. So what does centroid mean?
point of the
Exactly. It's the midpoint of the entire data set. So sorry, the points which are having common behavior, right? The distance from that point to the other points will be minimal. Clear? Now, so here I will walk through the code. Okay. So do you have this data set, Amazon sales clustering data set? No. Okay. Yeah, you can find in Kaggle. Clear? So here I'm using these three modules, which is import pandas as PD, import matplotlib.pyplot as PLT, and from sklearn.cluster import k-means, right? So you know the syntax is how it works here. Why you use alias here?
It's a short form
Short-
of
short-
pandas.
short-
You can perform.
Every time
Why?
we don't use pandas.
Pandas.
Exactly. Okay. So for example, this is an entire module. We will be having n number of attributes and n number of functions which are built in this module, right? Every time I cannot write pandas dot something, pandas dot some function, pandas dot some attribute, right? So I can directly use an aliasing name which eases my calling work, right? Clear? So that is why I have given aliasing. Import pandas as BD for doing operations on. Why we use that model? Import pandas as PD. Why do we use that pandas module?
Numerical.
Then why numpy? Exactly. So if you want to perform operations on the two-dimensional data structure, okay, here the data set is a two-dimensional data structure. You have data set like, sorry, what do we have in the data set? What do we have in the data set?
Rows and columns.
Exactly, rows and columns. That is why you will be having, that is why we say that is a two-dimensional data structure, right? If you have another value which is in the Z plane, then we say that it is a three-dimensional data structures. Clear? Everyone? So what is, like, what data structure or what type of data structure it is? Data set? It is a two-dimensional data structure, right? We use pandas module to do operations on the two-dimensional data structures, right? You can also perform an n-dimensional data structure. The complexity will increase. Clear, guys? Clear? Yeah. So that is the reason I have used pandas. Okay. Now I am using the second module, which is matplotlib.pyplot as PLT. Are you aware of this module? What does it will do?
Visualization, graphs.
I have other modules too. Folium.
For visualization purpose.
Sorry?
For visualization.
Standard deviation.
Louder, please. See. So in the plottings, you have variety of modules. Okay. When you select a module, it completely depends upon which dimensional data which you are using. Clear? So here, I can do plotting in the single dimensional data structure too. Right? What are those plottings? What are the plottings which I can do on the single dimensional data structure?
Why?
Right? Do I need an XY plane for that? Right? For the pipe, which is for matplotlib.pyplot, it has variety of two-dimensional plottings which you can do analysis with these. Clear? If you want to increase the complexity and if you want to go with three-dimensional and four-dimensional data structure, you can go with the folium. Right? For now, we are going with the matplotlib.pyplot. Clear? Clear, guys? Now, the third thing. From sklearn cluster, import k-means. Okay? So here, sklearn is a predefined module in Python which has n number of machine learning models which are embedded in it. Okay? For example, if you want to build a linear regression, everyone aware of this term, right? No. Okay, just listen it, okay? So if you want to build a linear regression, if you want to build a naive code, it takes 200 to 300 lines for sure. I will show you simply. So everyone are able to see the screen, right? So he has given some more detailed way. These operations are not necessary. So you have to do all these operations to do the linear regression. Okay. He had missed backtracking and everything. Okay. So here my intention is to, if you want, sorry. Okay. So if you want to build any model from the naive, from the starting, for sure it takes maximum efforts. Okay. So any model requires a cost function to learn it, right? So I already told you, when you ingest the data, model should learn it, right? For that learning, you use some cost function. Okay. If you want to develop a cost function, you have to be strong in these concepts like vector algebra, differential calculus, partial differentiation, right? Limits, and all these things. And then you can develop a cost function. Okay, for a linear regression, we use y equals to mx plus c and a gradient function. Okay, these type of things which you have to do. But with the help of sklearn, you need not to do anything. You just import the model, pass the input, it will learn something, it will predict something. Clear, guys? Everyone? Clear? Sleepy? No sleepy? Boring? Sure? Yeah. So you're understanding, right? Or like it was completely blank? You're understanding? Sure. Honest answers? No, sir. Yeah. So if you see, these are the three algorithms. Sorry, these are the three modules which I am using for my current task. Clear? Now, so how do you ingest data with the help of pandas?
data
Data from is if you want to create manually. If you want to create manually a data set, we use that. See, so I have already told you, when you ingest the data into the model, you completely deal with two-dimensional data structure, right? Where you will have the data in form of rows and columns. Clear? So if you want to pull the data to your machine learning work, you have to ingest the data with some operation, with some function. Yes or no? If I want to find a number is prime or not, what I have to be like, what should be my input? If I want to find a number, whether it is a prime or not, what should be my input? A numerical value which is in the real number set from plus infinity to minus infinity, right? In the same way, when you want to ingest, when you want to teach, or when you want to learn, like make model to learn something, you have to pass the data set. Okay, which is in the form of rows and columns, which is a two-dimensional data structure. Clear? So here I am using pd.readcsv. Clear? What does it do here? I am importing readcsv, a function from which module? Pandas module. Clear, guys? Clear? So here I am importing pd.readcsv. Sorry, I am calling a function readcsv, which ingests the particular data and it will convert into data frame, right? So here the main task is you will be having some file, you want to do analysis and you have to ingest that file to the model. So first you have to do is, you have to convert that model into a proper two-dimensional frame. So sorry, a proper two-dimensional data structure. Clear? So if you want to do that, you have to perform pd.readcsv, which reads only CSV files. Right? Here CSV means comma separated value files. CP? No? Right? In the same way, you can ingest any different type of file formats, Parquet, XLSX, right? And also you can ingest some PDF, any files. So you have all the built-in functions for that. Clear, guys? Clear, guys? So first step is you have to import the modules which you want for the model, and the second thing is pull the data to convert the file into a proper two-dimensional data structure. Clear? Now what is the third thing which you do? I'll give you the entire code, okay? Okay. What is the third thing which you do? So before ingesting the data set to the model, what is the first step? What is the initial step which you have to do?
First move to look up the data, how it format.
Sorry. So when you want to ingest the data, okay, to any model, the first thing which you have to do is understand the data, do EDA on the data. Yes or no? So before, I'm saying again, guys, even in the class or in the theoretical or in the real-time industry, okay, if you are into any industry, like in the data science industry, the first thing they will do is they will do EDA on the data. You won't be having a file of this much size. You will be having a file of 2 TB and 3 TB size. 3 TB means around 3 into 1024 GB. 1 TB means 1024 GB, right?
Yes.
So 3 into 1024 means around like 3000 some
70.
change it will be, right? So they will spend ample amount of months understanding the data, and then based on the data they will build the model. Clear, everyone? So here the one thing is you cannot directly ingest the data to learn something. Okay, first you have to make the data into chunks to get the proper answer. So I will tell you the simple scenario. You know about the Nokia mobile which is having the snake game. Can I install PUBG and play it? What it will happen? You got my question, right?
Yeah.
Everyone aware of the Nokia mobile which is having a snake game. Can I install a PUBG or Free Fire in it and can I play it? Or some snake and ladders or some like Ludo game? Can I play it? Why you can't? Because the computing power is not matches with the application you want to run. Right? That is so, like, this is completely happens in the real world, right? So when I work, the main headache is to maintain the pipelines and ensure they are not getting crashed. Okay, you have to make it more reliable. Multi-processing, like when you buy a laptop, what you will observe, like RAM, these things, right? So internally, RAM means the number of available CPU cores available in it, right? The more CPU cores, the more faster your laptop will be. Okay, you have n number of things which you need to observe when you're writing a machine learning model. Clear, guys? Clear? Making more, like, am I making more boring?
No.
Sure? Can I continue further? Sure. Honest answers. First, I need a charger. Yeah. So here, if you see, so the first thing which I do in the EDA, I have set the 3 operations. First thing is you have to remove null values, remove outliers, remove any duplicates if you find, and the third thing is find futures, right? Futures in any machine learning model, those are the suitable values or suitable columns from the data set which you want to ingest to the model, right? Here, future means the columns which are suitable to get to ingest into your model. Okay, so you are having n number of columns. Here, futures means you have to select the subset of from those n number of columns which you think those are suitable to for my model ingestion. Clear, guys? Yeah. So here, these are the operations which I have done for EDA. Okay. So the first thing which I have done is I have converted the entire file into a data frame, which is a proper 2-dimensional data structure. Okay. Before that, first I have to ingest it, and I have to see it how the data set is. Okay. So here I am using these functions. df.head. What does it will do?
Top 5 rows. Top 5 rows.
What does it will do?
Visualize.
So it will give top 5 rows from the data set, right? So let me execute it. So I am using these 3 functions: df.head, df.info, df.describe. Okay. df.head will give top 5 rows from the data set. df.info will give
Is there any
exactly.
manual
It gives the entire semantic representation of the data set. Okay, the entire semantic structure, like what is each column and what is the data type of each column. Clear, guys? df.describe will give
Like
statistical.
knowledge of the data.
Sorry,
Medium or
what does it mean?
aviation.
So here, describe function will give entire the quantitative information about the data set. Clear? Entire quantitative information. Clear? It means mean, median, mode, standard deviation, everything. Okay, it will give in a 2-dimensional matrix. Clear? Yeah. First, let me ingest the data. See, the first 5 rows, what are the columns I am having here now? Customer ID, product ID, product category, price, quantity, and rating. Okay, and also I have review count and purchase date. Clear? Now, so, and the second thing is info, data set info, right? Here I have printed 3 functions line by line, right? One is df.head, another is df.info, another thing is df.describe, right? df.head, which is given the first 5 rows from the entire data, from the data set what I have ingested, and df.info will give what it will give the semantic structure of the data set. Clear? Now, so here if you see the customer ID is integer value, product ID is integer, some product category is object. These are the data types which I am having in the data set. Clear? Now, the third thing is df dot. What does it will give?
Description about the
The quantitative information about the data set. Clear? So if you see, I have count, mean, standard deviation, minimum, how many points are which are in 25% quartile, 50% quartile, and 75% quartile, and all these things. Clear? Now, so if you see here, I want to give some more a briefer description here. So if you see here, the customer ID is of which data type? What does it mean? In 64 means? Size. Next. So when you learn C, you will learn these things. The int value range from -2 power 32 to 2 power 32. Did it make a sense? C. Which background you are from? Deform. Nice one.
Yes.
Seriously. Okay, fine. So when you want to store any data, for example, you know these things, right? If I initialize an integer variable int a equals to 5, what type of variable it is? Integer variable, right? So my point here is, when you want to store the data, it has only a specific limit. Okay. Here, when you store or when you learn C language, it will be in the range of -2 power 32 to 2 power 32. So those are the confined limits, the value which can hold in the C. Okay. Here, int 64 means it can hold the integer values which are in the range from -2 power 64 to 2 power 64. Clear? Did it make a sense?
Yes.
So 2 power 5 means some around 32, 2 power 64 means it will be a huge value. So it can hold the values from -2 power 64 to 2 power 64. Clear? And also here, there is a data type called objects. What does it mean? So for which column you are having the data type as object? Any other columns? Purchase date, right? What does object mean? Exactly. So it is a mixed string value. Okay, not a simple string. String means the values which rise from A to Z, capital A to Z, small a to Z. Okay. So object means it can accommodate different type of string values, different type of byte values, from ASCII from 0 to 128. Right? Clear? Now. So the third thing is df.describe means, which I have told earlier, it gives the quantitative information of the entire data set. Clear? Guys, one thing. So before this going further, I will tell you one thing. So in any scenario, in the real-time scenario or in the theoretical scenario, I will tell you a flow. Okay. When you want to build a machine learning model, first thing is you have to ingest the data and convert into two-dimensional data structure. First point. Okay. That is mandatory for anything, unless and until you are using for the NLP algorithms. If you're using transformers or BERT techniques, then it is the complete different scenario. Okay. Apart from those categories, when you want to ingest the data into any model, you have to convert that into a proper two-dimensional structure. Clear? That is the first point. Second point is you have to spend ample amount of time performing EDA on the data set to ensure data is noisy free and clean. Clear? What is the first step which I have told you? Convert the data set convert the file into a complete two-dimensional data structure. Second thing is do EDA. Okay. I think I have told you earlier, the more cleaner your data, the more accurate your model output will be. Okay. So guys, I'm currently working as a data scientist, I told you, right? So here my task is not to develop the code and not to develop the pipeline. Okay. Have to ensure my pipeline and my code is this scalable enough for the large amount of data too. Clear? So I have to ensure. So if you're working in these teams, like if you go further, like after this completion of course, or when you enter in the real-time scenario, writing code is not the big task, petty task. Okay. Maintaining the code to the large and voluminous amount of data is the hectic task. Clear? Clear, guys? Yeah. So the first thing is you have to convert the data set, or you have to convert the file into a proper two-dimensional data structure. And the second thing is do EDA on the data set. And the third thing is see. So the third thing is you have to select features from the data set. So what does it mean? You have to select features from the data set. It means you have to ensure what columns are suitable for my model. Right? I cannot ingest every column in my data set from my data set into the model. Yes or no? Right? For example, if I have a column called age, and if I have some, what I mean to say, some beneficial amount, or if I have some other column called hobbies, okay. So now my plan is from the government is to I have to provide benefits to the persons who are having age greater than 40 to some amount. Okay. Is it required to pull hobbies column into that particular model? No, because I already have age and beneficiary amount. Then why do I need to pull hobbies column into the model? Right? So that is what I mean. Okay. You have to ensure a proper feature selection for the model to ingest into the model. Clear? That is the third point. Fourth thing is load the data into the model. Okay. And the fifth thing is train the model if it is necessary. Otherwise, print the desired result. Okay. These are the 5 things. These are the workflow which follows in any industry. Okay. Theoretical, or if you go to the real-time industry, these are the 5 things which follow. Okay. Based on the complexity, it goes some more advanced: tuning, hyperparameters, parameterizing, these things which follow, right? But these are the 5 basic pillars for anything which you want to build a model. First thing is convert the particular file into two-dimensional data structure. Second thing is do EDA. Third thing is feature selection. Fourth thing is ingest that feature selection or the particular columns which you have taken into the model and print the result. Clear, guys? Clear?
Yes.
Okay. So any queries so far? So I will go with the entire code part. Okay. Any queries so far? Sure. Sure. Yeah. So as you see here, first thing is I have taken the data, converted into proper two-dimensional data structure, which is DF. What is the second step which I have done? EDF, right? What is the third thing which I have to do? Feature selection, right? See, select numeric features. Okay, this is where I have done feature selection, and then the next thing is the elbow method, which is like a tuning method for this machine learning model. I will tell you later. Okay, and then yeah, here I am applying the data to the K-means model, right? This is the 5 step which I have told, and I have implemented it. Clear, guys? This is the thing which follows in anything, guys. Like theoretical, like if you see in the theoretical or if you see in the real-time industry, this follows. You have to remember this very clearly. Clear, guys? Clear? Now, so here, if you see, in the part of EDA, I told you, like I should handle null values too. Okay. So we have a function called fill_NA, which will fills the missing values in the data set. Okay. Clear? Now, so I have also a function called drop_NA. Okay. What it will do? Drop the null values. Like why I haven't used it here?
Future sites won't be accurate.
Sure.
Future
So you got my question, right? Yeah, your answer is valid thing. So here I have handled null values with the function called fill_NA. Okay, it will fill all the values with the mean of those particular numerical values. Right? Clear? I will explain this some more deeper. First thing is why I have used only fill and not drop and
Because we lose the data.
Because you can't use- yeah, that
We
is-
lose the data.
Exactly, this is the point. Okay. For example, I have 100 records. In those 100 records, I am having 98 records which are having some null values. If I do drop an A, how many records I will be left with?
No data. We need two records.
Two records.
What is it?
Why I will spend thousands of dollars to ingest the data into the model, right? So here I have these free resources, right? So when you're in the real-time industry, you will pay for everything. Okay, you have a cloud called Azure, right? You have a service called Azure ML service. Okay, for every ingestion and for every ML technique which you apply on the dataset, you have to pay some amount. Okay, for those two records, I have to initialize the model, some amount. Okay, I have to get some output and also some amount get deducted, right? It's like not an optimal thing, right? So that is the thing. First thing is you have to ensure the data is populated with some meaningful values. Okay, Fillania is the one of the thing which fills all the missing values with the mean values. You know what does mean do, right? What does mean do?
Average of
It calculates the average. For example, if I'm having the price range from 1 to 10, if you want to calculate 1 plus 2 plus so on plus 10 by number of observations, 10 observations, it will give that value. So in this price column, the points where I have missed, it will fill with these mean values. Clear, guys?
Yes.
Clear? Everyone? Clear? Now, so here I have used another parameter in this function. What it is?
plus equal to.
In place equals to true. What does it do?
Suppose it's the null
Fixes
value is
the-
there.
Conveniently.
Based on that.
Okay, nice. That is correct, but proper terminology. What does in place equals to true do? So here,
Fixes the changes.
exactly. So it will override the existing operation which you have done to the data set. What it will do? It will override it. For example, if I'm having a missing value in the 5th row where price is null, okay, when I perform this operation and when I pass this in place equals to true, it will fill that mean value. Now the value which I am not having in the 5th row will be populated with some value. Now my data set will be a new data set without null values in the 5th row. You got my point, right? Clear, guys? So here in place equals to true means it will override this operation to the data set. Clear? Now, so in the same way, I am doing for every column: price, quantity, rating, and review count. Okay. So what type of data type these columns are?
Integer two.
How you have said that?
Mean.
Because we are doing the mean.
Exactly. So here you are performing mean. You cannot perform mean on the qualitative data. If I'm having a string of 10 values, can I perform mean on that? I cannot do that. Okay. These all are numerical features, right? These are the 4 features which I'm going to select in the model. So that is the reason I'm handling all the EDA on these 4 columns. Clear? If I'm having 256 columns, I need not to do everything. Okay. I have to do EDA on only the columns. Those are features which I want to ingest into the model. Okay. I have to concentrate only on those future columns. Clear? Clear, guys?
So
No.
why mean? Why not mean?
You can do it. See, if you go for median means the more like the middle value, right? It will first sort that value from ascending to descending, and it will give the middle value, right? For example, let us say I am having the price some imbalanced values, some 10,000, 50,000, right? If you do median, the values will be like it will have a huge difference from other points. If I do mean, then the difference will be like a balanced way. You're getting my point? You're getting my point? If I do median, the balance will be more. Okay, I'm using mean to get a proper balance from the points from other points too. You're getting my point, right? Clear? So this is how I handle null values. And guys, this is one of the way. Okay, I will just print it. Yeah. So this is one of the way where I can detect outliers in a column. Okay, which is a hist plot. Yeah, histogram, right? Which type of plot it is? It is a one-dimensional, two-dimensional plot. How we have said that? You got my point, right? You said that histogram is a two-dimensional plot. How we have said that? XY is the two-dimensional. How you have said that? You're getting my question, right? So you said you are having one-dimensional plottings too. We are also having two-dimensional plotting. Don't say because we are using pipeline that is the reason. Two-dimensional plotting. Okay. See, here histogram is a two-dimensional plot where you have two variables where one variable is dependent on another variable, right? So why do you use two-dimensional plot? To see the behavior of one point with respect to another point. That is the reason we use two-dimensional plot, right? Yes or no? So the plotting which I have given you, I have given some 10 plots. So in these 10 plots, what you have noticed? You have said that one point which is dependent on exactly one point increases, another point increases. That is the point, that is the intention why you use plotting, right? Now, so this is one of the best technique which shows outliers in my particular column. Okay, the plot which I have used is histogram, right? So after executing this, I got some distributions like this. You're seeing this, right? So if you see here, price outliers, right? And also some quantity outliers, rating outliers, review outliers. Okay. So if you see here, I'll go with one of the plot. Okay. If you see in this plot, rating outliers, what is the values I'm having on the x-axis? Ratings. On y-axis, number of users or number of people. So if you see here, I have some around 100 users given one rating, right? In the same way, I am having around like near more than 100 people which they have given 5 rating, right? So how do you get it like outliers in this? Okay, I don't have outliers in this column, but let us consider a scenario where I have a rating like 10 here, which only one user have given a rating called 10. Is it a valid scenario?
No.
How you have set that? In the Amazon application, what is the rating value or rating range you have? From 1 to 5, right? If you have a plotting where it is having value as 10 rating and around like some n number of users have given the rating as 10, okay, it means you clearly say that I am having this Amazon application and the rating range from 1 to 5. How can a user give 10 rating? Okay, those points are called outliers. Clear, guys? Clear? So these all conclusions will be getting you from a business analyst. Okay. So if you want to do everything, it will take ages to do. Okay. So business analyst is the one who feels or who will make you to understand what data is, how it is behaving. Clear? Yeah. So you understood, right? How outliers behave? Clear? Now, so I have done EDA, and what is the next step? What is the next step? Future selection, right? So if you see here, I am ensuring so in this line, okay, in the entire data frame. So in the entire data frame, I have taken only some subset of columns, which are price, quantity, rating, and review count. And these columns I have suggested as futures, because when you suggest a future, it means those are the suitable columns to ingest them into the model, right? Earlier I have told you, right, age and some beneficial things, right? If a person is having hobbies, if it is not relevant, don't use it. Okay, that is the only simple way to tell what does a future mean. Clear? Sleepy? Got it, right? So here, futures means those are the suitable columns where my model needs to learn. Simple definition. Clear, guys? Any queries so far? Boring? Sleepy?
So based on what criteria did you selected the
See, I have given randomly. So the thing is, if you see, I am having some 8 columns, right? Other 2 are object type, right? So I have taken the entire remaining 4 columns which are normal type to my future selection. Okay, you can take 3 columns too, but you have to understand whether I'm giving the correct data or not. Clear? Clear? Yeah. Any queries so far? Any queries? Yeah. So before starting k-means, this is elbow method is an optimal technique which says how many number of clusters I need. Okay. Earlier everyone had done plotting, right? How many number of groupings or how many number of clusters we have? 2 clusters. Okay. You don't know whether this is an optimal or not, but you have said based on your consciousness, right? So for example, let us consider a scenario. If I'm having 1000 members, right? Is it optimal to put 1000 Pani Puri starts in this 1000 members? How many stalls do you need? 5. You got my point, right? If I have 1000 members, okay, for those 1000 members, can I establish 1000 Pani Puri stalls? How you are telling that? Consciousness. Because do you like Pani Puri? How you are saying that? You are saying roughly like it's 20 to 30 will be enough, right? In the same way, clustering works. Okay, those cluster points are the Pani Puri stalls. Okay, all the 100 points are dataset points. Okay, you have to be very optimal way. If I have 100 members and if I have Pani Puri 100 stalls, then that person will be bankrupted. Yes or no? Yes. So you have to be select in an optimal way. Clear, guys? Clear? So to select that in an optimal way, we have a technique called elbow method in clustering algorithm, clustering machine learning model. Clear? Which says how many number of optimal Pani Puri stalls I need for the 100 people. Clear, guys? Clear? Yeah. So I will execute this entire thing. Right, I will give you the code. Okay, when you're having a free time, when you have free time. Okay, you can go and you can have it check. Okay, so because this is the real things which we do in the industry. So the random set follow to and also inertias, these terms which we use in industry. Okay. So if you see here, I have some plotting here. Okay, everyone, are you able to see this? Yeah. Before explaining that, I will tell you the code what I have done. Okay. So initially, I have some points in the data set, right? I don't know how many number of clusters I need. Okay, guys, just match it with the Pani Puri stalls. Okay, I have 100 members. I don't know how many stalls I need. What I will do? Initially, I think 100 is the correct number. Initially, I think 100 is the correct number, but that is the worst case scenario, right? I don't know how many number of stalls I need. What I will do? I will do some 100 as a random number. Clear? From that 100, I will calculate. I will pass 1 to 100. Okay. Here I have given 11 only. Just think in that. Just make it a similarity. Okay. So for each stall, I am calculating the inertia. Okay. What I will do is I am initializing model k-means and n clusters equals to I. Okay. What is the I value starting here?
1,
What is the ending value?
10.
10 means for all the points, it will take one cluster. Again, in the second iteration, for all the points, it take 2 clusters. Again, for the third iteration, for all the points, it take 3 clusters. In the same way, for 100 numbers, first it will take 1 Panipuri stall, and the second iteration, it will take 2 Panipuri stalls, and the third iteration, it will take 3 stalls. Only for 100 numbers. The points are constant, but my clusters are changing, right? So here, I will randomly plot, right? For until 30, for 30 stalls, for 100 data set points, okay? It will randomly plot it, okay? Once plotting, see, this line what it will do is, I am taking that model and I am initializing clusters to it. And then I have given another value random state equals to 42. This random state equals to 42, what does it do means, when you execute multiple times, it won't alter the result. It will give the same result each time. Okay. So simply I will tell you, if I give a number is 2, if I given an integer value 2, if I want to find whether a number is even or odd, what will you do? Modulo 2 or some like a bit operator with 1, any operation, right? So here you are doing, when you execute the code multiple times or 100 times or 1000 times, what is the output you will get? Whether even or odd. Sure. Okay. See, so here random state 42 will do is, how many number of times you execute the code, the answer or the result won't vary. It will make the result consistent. Okay. That is the reason I am using random state equals to 42. It varies from 0 to 100, but this is the best value we have to give. Okay. Clear? Now, I have initialized the model, and what I have done here, k-means.fitx. Can anyone tell what does it do? Or just tell me, like, what you have noticed from that line?
Random.
Sorry?
Any random.
k-means.fitx. Just in our consciousness, like, what you understand, what does fit means? You're getting my point? Fitting means, see here. What is the x value there? What is the x value here? The entire data set which is having futures, right? I am ingesting the data to the model which is having C. So here if you see, what is the first iteration I'm having here? For first iteration, how many clusters I'm having here? 1 cluster. For that 1 cluster, I am ingesting the data. Yes or no? And I'm calculating the inertia. Inertia means the point, I am creating a center right there, from that center point to all the points. Okay, the summation distance. Okay, for example, if I have some random 10 points, if you want to calculate distance between those 10 points, what you will do? x2 minus x1 whole square plus y2 minus y1 whole square. Right? For all the points, you will calculate like that. In the same way, inertia means from that center point, from that cluster point to all the other points. Clear? Clear, guys? See, for each cluster, for one, considering 1 cluster, I am fitting the data to 1 cluster and then I am calculating inertia. Again, I am taking 2 clusters in the second iteration. I am again fitting the data for the 2 clusters and again I am calculating inertia. Any queries so far? Sure. Can I ask someone to explain this?
Random state, it will be like same every time.
Yeah, you can keep it. It's a static value. It varies from 0 to 100.
If I get any data set.
It doesn't change. It won't change. So it doesn't depend upon the data set you ingest. The only reason I have used is, for example, if it without random state, if you execute this code, I make a different value. You make a different value. To maintain that consistency, I have used the random state equals to 42. Any queries so far? Sure. Can I ask questions? Lock saver. One user. Sure. So you got my point, right? So this is what I will do is I am initializing 1, 2, so on clusters for each iteration, and I am fitting that model the data which what I'm using, and then I'm calculating the inertia. Okay. Now I am plotting the graph. Okay. PLT.plot. What is it will do?
Not the rate.
Just a plotting. What you have done there, right? What you have done in the books, do just do the plotting. That's it. Clear? So here, range 1 to 11. What will be output for range 1 to 11? Python.
1 to 10.
What 1 to 10? We're not here. Range 1 to 10. What like what will be my output? A list of values from 1 to 10. Yes or no? And then WCSS. What does it mean?
Happen.
What WCSS means? Here is another list, which is a list. I'm appending inertia in that list. Okay. What is the length of this WCSS?
Then
How you have said that?
there is 1.
Exactly. So here I am calculating for in range of 1 to 11 for each cluster. I'm calculating inertia, and I'm appending that inertia value in WCSS. Means if you see here, the range values from 1 to 11 is the same length of WCSS. Clear, guys? Now I am plotting the range values for each cluster and what is the inertia. Clear? Now, so in the X label, what I have given? Number of clusters. In the Y label, the inertia. What is inertia here? Okay. So here inertia means the summation of distance from the centroid to each and every point in the cluster. Okay. So in the plotting, if you see, you have said that I have 2 clusters here. Okay. What clustering algorithm do is it assigns 2 clusters for it. Okay. From that centroid to each and every point. Are you getting my point? Everyone. So what does inertia mean here? When you plotted it earlier, you have 2 clusters. You have said that so there are 2 groups, right? In those 2 groups, their model will assign 2 clusters for it, which depicts that these 2 groups shows a common behavior. Clear? Inertia means from that cluster point or from the centroid point to all the points which you have in the group. Clear, guys? The summation of distance from that centroid to all the points in the group. Okay. For example, if I have a centroid from here and all other points here, inertia means this point to this point the distance, this point to this point, this point to this point, this point to this point. The summation. Clear? Not WCSS. Okay. Clear, guys? Now, so once plotting this, see, if you see here, what are the values I'm having on the x-axis? Okay, cool. So what are the here? What I am having? 1 second. Let me make it more clear. Yeah. So here in the x-axis, what is the values I'm having there? Number of clusters. On y-axis? Okay, I agree with you. Okay. See, so here for 2 clusters, I'm having inertia value here. Guys, it is the large value. See, I'm having the values in 1 e power 9. Means e value is around 2.73. 2.73 power 9 means it's a large value. Okay. It is not showed here, but is the in the calculation of 1 e power 9. Clear? So for 2 clusters, I'm having inertia here, right? For 1 cluster, which is the value here, I'm having the inertia here, and 3 clusters, inertia here, 4 clusters, inertia here. Okay. So in the elbow method, the optimal number of clusters are the bend where you have seen the curve. Okay. You have seen a curve here, right? You have seen a curve here. Tell me the point where it's changed its behavior. 2? Sure? In between 2 or 4? Okay, again. In between 4 and 6?
No.
You got my point, right? Here in the elbow method, the optimal number of clusters are the point where in the curve change its behavior. If you see here, from here to here, it is shown some behavior like this. Okay. In the scenario where it is having 3 clusters, it changes its behavior. Yes or no?
Yeah.
So what I can conclude here, how many number of clusters I need here? 3 clusters. It means I need 3 Pani Puri stalls for entire 100 persons. Clear? It will be a huge mess, but just for your reference. Clear? So it need only 3 clusters for all the points which I have. Okay? You got my point? Now. Sorry?
Repeat once.
Sorry, yeah. So here, elbow method is used to calculate or to find optimal number of clusters I need for all the points. Okay. See, earlier in the plotting, how many points or how many groups you have noticed? 2 groups in the plotting. How many clusters you need? 2 clusters. It means those are the 2 points or 2 groups which are showing a common behavior in them, right? So I have given 8 points. You easily said that. What if I given 1,000 points? You will spend the entire night to plot and you will guess it? No, right? If I give 10,000 points, you will take the entire semester. That's not the scenario, right? So to calculate how many clusters I need, I use this elbow method. Clear? Okay. To calculate that, I will initialize a model with 1 cluster, 2 clusters, 3 clusters, so on, and clusters. I don't know what will be the optimal point. I will just randomly initialize clusters and I will calculate the energy. Ma'am, he is understanding my lecture excellence. Okay, you got my point, right? Here the number of clusters were the reason why I'm using to find the number of like the optimal way to find them, right? Understand? For example, just to make a parallel scenario with the Pani Puri stalls. Okay, for 100 members, or okay, make it biryani stalls. I'm not biased. Okay, so for example, 100 persons, if I take 100 biryani stalls, it won't be optimal. Ma'am, is there any problem? Okay, it won't be an optimal way. So the optimal way is I am considering some random 30 stalls and I am calculating the inertia, and based on the points, I will ensure what is the number of clusters I need. So simply, guys, so for example, tell me the answer. I am having a 300 people in in one place, and 400 people in another place, and 100 people in another place. Okay, I have to establish some food courts. Like how many food courts do you need?
3. No, we measure the distance and keep it 1 only.
Okay, you're more optimal than me.
He's doing summation.
Yeah, so 3 will be more optimal, right? So if you give 1, then 3 won't serve anything, right? So for 3 points, like for the 3 groups, like we are having 300 people, we are having 400 people, we are having 500 people. Based on that, I will assign this cost. The same thing happens here, right? So here the thing is, I said statically like 300, 400. What if I'm having large voluminous number of people? I cannot count every time and I can't keep it, right? So that is the reason I'm using this elbow method. Clear? I'm randomly initializing some clusters, I'm calculating the inertia, and I'm finding from it. Clear, guys? Clear? For all the data sets, I have initialized some 10 clusters, and in the 10 clusters, I have noticed 3. So if you see here, I have depicted a curve here. Okay. Here, how do you find the optimal number of clusters means the point where the curve changed its behavior. That is the point where the number of an optimal number of clusters you need for your points. Simple, ga? Like the number of stalls which you need for 100 members. The optimal number of stalls. Clear, guys? So here I have set that point, the point where the curve showed or the curve changed its behavior. Yes or no? What is the point the curve change its behavior? If you see here, see, if you don't say like, sir, why can't you say like this? Okay, I am plotting from left to right? So you have to start from here. Okay, so here, if you see here, from this point to this point, I am having some linear behavior. When you see here, I am having the change of the curve behavior at this point. What is the point where, like, number of clusters at this point are 2 to 4. Like, what is the middle point? 3. So 3 are the optimal clusters which I need for the entire data set values. Clear? Any queries? Sure. Okay. Can I continue further?
Yes.
Is there any other way to find that? So,
Elbow method is the other way for the curve.
no, like finding the
Optimal clusters.
Yes.
Elbow method is the optimal. Only man method. There are other methods finding the median and everything, but the thing is, so when it gives 3 as the value, I have to plot it again, and I have to see it. I cannot blame the method which I'm using. I have to blame only the data set. If he had given the correct values, I cannot predict it, right? So see, the values which I have given or I have taken randomly from the data set and I'm predicting it. Here my concept is to teach you the methodology how it follows, not the correct or wrong answer. Follow the methodology or follow the instructions. You may get answer, you may not get. Okay, that is what data science. Okay, they won't get answer for sure. So I spent 18 months to change the value of an algorithm, to tune an algorithm from 2.78 to 2.68. 18 months. I have shifted to this company like in 2024 April. Okay, and then I have working on the same algorithm, same update in the Scrum. So 2.67, so 2.68, so 2.79. So it takes that much time. Okay, here your task is to not get the correct answer. Your task is to ensure you are getting the correct answer. Okay. Yeah. So if you see here, so guys, is it clear so far? Just understand this. I'm not expecting you to do after I'm completing it. Okay. Just understand the flow and what I have on it. Clear, guys? Clear? Any doubts in the elbow method? No? See. Now, if you see here, what is the optimal number of clusters I have obtained there? 3. So that is the reason. In the line, if you see here, K means I'm utilizing a model with. These are the optimal clusters which I have needed for all the points. Okay. Now, what is the value I have taken here? And I'm equals to 42. Sorry. So if you see here, I'm taking another column, D update cluster, K means dot fit predict. Okay. If you see in the earlier, okay, I have ingested the data with the function called fit. Fit predict will give all the centroids. Okay. All the thing is, here our task is to find the clusters where it resided. Okay. Fit predict will give all the geometrical information of the clusters. Geometrical information means where the points are resided. Okay. You're getting my point, right? Everyone. Or should I explain it once again? Yeah. So fit means it will just ingest the data into the model. Fit predict, what it will do is it will give all the geometrical measurements of this model. Okay. I have taken the clusters, 3 clusters. It will give all the geometrical information of these 3 clusters, like where they have located in the XY plane. Okay. What are the centroid values? Okay. What are the attributes, like whether they are in the positive coordinates, whether they are in the negative coordinates. It will give all these informations. Clear? Now, so I am plotting the centroids and the futures. Okay. If you want to plot a centroid, what do you need? In XY values. I am already having them in cluster centers. That is the reason I am using I am using an attribute cluster centers where it will bring the coordinates for the clusters. Okay. Clear, guys? So once after executing this, if you see here, I don't say this is the correct answer, okay? Okay, but it is an optimal one for sure. Okay, how many clusters I have used? For the entire dataset points, where I have selected futures, right? So if you see here, I can consider this is a minimal distance from all the points. Yes or no? Yes or no? Because if you take a cluster here, because I don't know, I'm just saying, if I take a cluster here, will it be a minimal distance from all these points to this cluster point? So here the blue marker is there, right, which are in the X shape. Those are the cluster centers where my model predicted. Clear, guys? Clear? Now it should be in a such a way the minimum the distance from these points to this point will be minimal, should be minimal. Okay. If I take a cluster center here, will it be optimal? Because the distance increases from this point to this point, but it will be minimal here. Okay. If I take here, will it be minimal? If I take here, will it be minimal? So if I taking in the center, it will be a minimal points. Clear, guys? Clear? It means we are having only how many clusters?
3 clusters.
3 clusters. Don't say 1 cluster because everything randomly distributed. Okay. So the thing is, that is what I said. That is what I want to say. Okay. You have to ensure that data is clean and ready for the model ingesting. So I cannot take this data and I cannot give a conclusions. Okay. I just want to show you how a clustering algorithm works. Clear? And how do you find optimal number of clusters needed for your data set? Clear, guys? Clear? That's it. Any queries so far? Sure? Sure. So tell me, how many number of clusters I have used there? Not optimal. Generalized.
Yeah.
If I increase to 20, will it change or not?
Yes.
It will change, right? So let us see that too. But the distribution happens in the center itself. Let me give 20 clusters here. Oh, the shape increased. My bad. So when you plot, you should have the same size. X and Y value should be the same size. See the same thing. Okay, what is the point where I'm having here? Like around, yeah, around it is 3 or around this. These are the number of that's it, right? So I'm having 20 clusters here. So here it follows the same behavior, and this is the point where the behavior has changed in the curve. So this is the minimum number of clusters. That is the one way you can do. That's it. Do you need this code? Sure. That's that. Like, will you do in your free time? Sure. Yeah. Any queries? Any general queries? Or you want to learn? Or you want to know? Which stream you are from, everyone? Like you said, you are from pharmacy. CSC. Yes. Everyone.
BC.
Huh?
BC.
BC. Sorry. Any queries? No? Like how do I share this code? Yes, do you understand? Honest answers. Like if you're like first time, it will be messy for sure. You won't understand it. So if you have to run multiple times, you have to understand like what does each skill do. Clear? See, the entire data science and machine learning, all this works on the visualization and the statistics. Okay, I told you, right? Vector algebra, differential calculus, partial differentiation, and limits and probability statistics. These are the 5 and 6 pillars of the entire machine learning field. Clear? So if you remember, tell me, like you are aware of this Ghibli trend, right? Ghibli, that trend. Right? You're aware of this trend, right?
Yes.
No? You're aware of this trend, right? So tell me, You're just giving some sentence in the chat GPT to generate some image. For example, if you give some image and it will give some other person's image, will you accept that? For example, if you give your image and it will give some Sanjeev or some other person image, will you accept it? How model interpreted that? You're not giving your photo and you're giving your photo, I accept it. But it is generating or it is rendering based on the inputs you have given. How it is happening? Sorry?
CNN comes in picture.
Huh? CNN, yeah, it comes. Multi-level neural networks, it comes there. So everything happens. Every algorithm, it will learn multiple times to give the output. That's all. See, I told you, right? Writing a code won't be a hectic task, but making your code scalable with the data is a hectic task. You will sleep at 1 o'clock and you will get a phone from your business analyst. Array, this pipeline was broken. You have to wake up and you have to fix it. You got the concept, right? Any queries? So I will give you the code. Okay. Honest answer. Okay. So you can refer it and you can execute in your interpreter. Okay. Follow Google Colab. Okay. Like if you want to do in VS Code, you can do it, but modules may not be available. You have to install those modules explicitly. Clear? Record this. Guys, any queries who are joined in the online? Data will be in the audio stream, video stream. This will be no. How many? What can be? No. No, they understood well. I'm not understanding. You guys got it right, like how the helicopter, like how it happens, right? How it flows. So I said the 5 points, right? Like converting the proper data structure, feature selection, ingesting, and the points which I have told you, EDA. Those are the typical workflow follows in the real-time industry in the theoretical way. Okay, that's the basic thing we have to know. Building model, it's your extension. It's your base. It's our the thing is like it's your capability. Closest one.
సూపర్వైజర్ లెర్నింగ్ క్లాసిఫికేషన్ ఉంటుంది
How?
అది అవుట్పుట్ అన్ని కేటగిరీ
0 and 1 spam and not spam అలా వస్తాయి.
అప్పుడు 0 and 1
No. Like so 0 and 1 వచ్చినప్పుడు ఏం చేస్తామంటే we will be having high level data here. So ఇక్కడ for example in the supervisor what you have said here, so for example let us take email. Okay, do model know what spam and what's not spam is? Do model know? Model don't know those things. See, if you want to ensure model will learning something, you have to give instructions very clear. model won't understand high level details, high detail values, spam, not spam. Those are the fancy words. Model won't understand those things. You have to convert those values into proper machine understandable values. Like I will assign those values into one. Okay, spam means one, not spam means 0. Okay, for example, if I'm having 100 emails, I will assign 1 for spam, 0 for not spam. And then I will train those 100 emails to the model. Model will learn something, and then I will pass another test of 20 mails. Then model will give an output whether the given value or given mail is spam or not. Clear? So there is a function. I don't recall that. Bit transform, the function will be there, which will convert all the category values into proper numerical values. Spam, not spam, true, false. Those values will be converted into 1 and 0s. Okay. So you can write a Python code for that. That won't be much fun.